Hey guys, welcome to the video for graphing standard form. We're in Unit 3A. Our essential question is, why are multiple representations important? So previously we have learned how to graph slope-intercept form and point-slope form, and today we're going to learn how to graph standard form. So just a reminder, the very first form that we learned how to graph was slope-intercept, which is y equals mx plus b. Why is this called slope-intercept form? Well, it's called slope-intercept form because it gives us a slope and an intercept. And remember that intercept is a y-intercept. The second form that we learned was point-slope form. Okay, the second form we learned was point-slope form, and the reason why it's called point-slope form is because it gives us a point and a slope. The slope is always represented by the letter m, so that what gives us our slope. And then the point, remember, is going to be these two values, which are x1, y1. And the weird thing about this one is that the y is in the front here, so you want to make sure that when you put it into the point, it goes second. And with point-slope form, those signs are always opposite, so you have opposite signs here. Okay. The very last form we learn how to graph is standard form. Now standard form looks like this. ax plus by equals c. And just like with all the other forms, they all have an x and a y in them because a linear equation needs an independent and a dependent variable. And just to let you know that a, b, and c's are just constants. They're just regular numbers. And yes, there are variables in their place right now, but they represent numbers. So they're just numbers. And you'll see that later on. So ax plus by equals c. This form is also a little bit different from the previous forms because the x and the y in this form are on the same side. So if we look back at slope-intercept form, our y and our x were on opposite sides. We have y on one side of the equal sign and x on the other side of the equal sign. With point-slope form, we have y's on one side of the equal signs and the x on the other side of the equal sign. But with standard form, x and y are on the same side, both on the left. So that's going to be a key thing when we're writing standard form equations, but today we're just graphing them so they give them to us already. In order to graph standard form, we need to talk about what an x-intercept and a y-intercept is. So just a reminder that the x-intercept is on the x-axis, and it normally has the form number, 0. So for example, 5, 0 would be an x-intercept, and it would be intercepting the x-axis at the point 5. A y-intercept is on the y-axis, and that's 0, number. So you have a number in for the y. And we've learned how to solve for x and y intercepts already, so if you have forgot, you'll need to review that, but we will go through it in these notes. One more thing before we move on. I know I think there's only 6 examples we have in here. There are 6 examples with graphing, but I am going to show you one extra at the very end about intercepts, just so that you know, because you might run into that to a certain problem. So I just want to make sure I cover that as well. So the first thing we're going to do is we're going to graph the equations in standard form. Now standard form doesn't really give anything away. With slope-intercept form, it gives us a slope and an intercept. With point-slope form, it gives us a point and a slope. But standard form doesn't really give much away by just the name of it. So in my opinion, it's one of those forms where it's just like, okay, it's just what it is. So in order to graph from standard form, the easiest thing to do is to find the x-intercept and the y-intercept. So in order, I need to silence my phone. In order to find the x-intercept and the y-intercept, I want to give some space to do that. So I'm going to go ahead and divide up my workspace into 2 parts. On the one side, I'm going to find the x-intercept. And I know that that's going to be number, 0, and I don't know what that number is, so I'm going to have blank, 0. And on the other side, I have a y-intercept, which would be 0, blank. Remember, an x-intercept and a y-intercept are points, okay? So you don't want to say like, oh, the x-intercept is x equals 9. Like, yes, it does equal 9, but the intercept itself is 9, 0. So in order to find the x-intercept, the first thing I want to do is going to write the equation down. So I have 8x plus 4y equals 16. Now for the x-intercept, I know that I have always for any x-intercept that there's a 0 in for the y value. So I'm going to plug in a 0 for the y value here. So 8x plus 4 times 0 equals 16. Well, 4 times 0 is just 0, so it just goes away. And then I have 8x equals 16. To solve for x, I would divide both sides by 8, and I get x equals 2. So what does that mean my x-intercept is? my x-intercept is 2, 0. So I'm going to go ahead and plot that point on my x-axis. Remember, your x-intercept's on the x-axis. Okay, now I'm going to find my y-intercept. So the first thing I'll do is write down my equation again. But this time, I have a 0 in for the x value. So since there's a 0 in for the x value, I'm going to plug in a 0 for x. Okay, 8 times 0 is 0, so that goes away. 4y equals 16. Divide both sides by 4 to get y by itself. And then I have y equals 4. So my y-intercept is 0, 4. And I would plot a point there. I'm going to go ahead and draw my line through these 2 points. Now normally I like to have 3 points, but when we have a standard form equation, I do like to have just those 2 points using my x-intercept and my y-intercept. This isn't the first time we've seen standard form, and I'll show you where we've seen it before previously. So we've seen it when we were graphing slope-intercept form here. So for example, we had 3x plus y equals -2. This was in standard form, but previously we would solve for the y and then get it into y mx plus b form. But we're not going to do that anymore. We're going to use the x and y-intercept to graph. Okay. So, and just in case you haven't recognized this as standard form, your a here would be 8, your b here would be 4, and your c would be 16 for the ax plus by equals c. And just by looking at this graph, I already know that this slope would be a negative slope because my 2 points have a negative slope here. Okay, it goes in the negative direction. And I could solve for the slope by getting y by itself, but I don't really need to. All right, with number 2, I'm going to do the same thing. I want to get the intercepts, so I'm going to find the x-intercept on one side. And I know that's going to be blank, 0, and the y-intercept on the other side, which is going to be 0, blank. So I'm going to have 3x minus 2, and this time I'm going to be plugging in a 0 for the y because I'm finding the the x-intercept, sorry. When you're finding the x-intercept, you plug in a 0 for the y. Well, -2 times 0 is just 0, so I have 3x equals 12. Divide both sides by 3, and I get x equals 4, because 12 divided by 3 is 4. So that means my x-intercept is 4, 0. So that's going to be positive 4 on the x-axis here. And then for the y-intercept, I would be plugging in a 0 for the x value because it's always 0, number. I always have a 0 in for the x. 3 times 0 would become 0. So then I would have -2y equals 12. And then I would have to divide both sides by -2. So y equals 12 divided by -2, which is -6. So -6, or 0, -6 would be my y-intercept here. And so that'd be 1, 2, 3, 4, 5, 6. Okay, draw a line through those 2 intercepts, and this one would be a positive slope. So if I were to solve for y and get it into y mx plus b form or slope-intercept form, I would see that I would have a positive slope here. All right, so we're going to keep practicing graphing standard form here. So I'm going to find my x-intercept on one side and my y-intercept on the other side. If you think you've got it, go ahead and pause the video and try it on your own, and then just kind of skip through to see if you got the answers correct. So here, remember, your x and your y technically do have a 1 in the front, right? It's 1x plus 1y, but you're just plugging in 0 for y, so this would be x plus 0 equals -2, because when I plug something in for a variable, that variable is no longer there. So since I'm plugging in a 0 for the y value goes away and I plug in a 0 for it. Well, x plus 0 is just x. So I have x equals -2. So my x-intercept would be -2, 0. So that's going to be on my x-axis on the negative side over there. And then on the y-intercept side, I would be plugging in a 0 for the x. So anytime I plug in, I always use parentheses. So that's going to go away because it's just 0, and I have y equals -2. So I also have 0 equals -2. So I have -2 for both values here. So on my y-axis, I have a -2 intercept, and this would be a negative slope. Okay. Number 4, same thing. Going to solve for the x-intercept and the y-intercept. So when I see something in standard form, it is best for me to just find the intercepts because it's a lot quicker than having to solve for the slope and the y-intercept. But with the slope and the y-intercept, at least you get the y-intercept. You just don't get the x-intercept, and we might need that. All right, so again, plugging in a 0 for the y value since I'm finding the x-intercept here. -3 times 0 is just 0. X equals -6. So my x-intercept is -6, 0. Then I'm going to plug in a 0 for the x value here. Well, that's just going to cancel, and I have negative 3y equals negative 6. Divide both sides by negative 3, and I have y equals positive 2. So I have 0, 2. So my y-intercept's at positive 2 on the y-axis, and this one's a positive slope. All right, moving on. So here we're going to find the x-intercept and the y-intercept of each equation. So this is basically the same thing we've been doing, except we're not having a graph, so that's kind of nice. It's just kind of more practice for us to find the x-intercept and the y-intercept. Every problem is a little bit different, so sometimes you'll run into some challenges that you won't run into with previous problems. Okay, now it doesn't matter which intercept you find first, right? But I just like to start with the x-intercept. So you plug in a 0 for the y value here. Well, negative 0 is really just, or minus 0 is really just 0. So I have x equals negative 4. So my x-intercept is negative 4, 0. For the y-intercept, I would plug in a 0 for the x value. Well, 0 just goes away, right, because it's just 0. And then I have negative y equals negative 4. My y is not by itself yet, so you need to divide both sides by negative 1. Okay, negative 1 divided by negative 1 is just 1, so they cancel, and I get y equals negative 4 divided by negative 1, which is positive 4. So my y-intercept would be a positive 4 here. So on this step, we had to do the extra step of having to divide by negative 1. Moving on to our next example here, we're going to find our x-intercept first, and then our y-intercept. Okay. Here I plug in a 0 for the y value. Okay, well 8 times 0 is just 0, so I have x equals negative 16. So my x-intercept here is negative 16, 0. And the only time that you would really screw up or mess up on these x-intercept and y-intercept problems if you just really forgot what an x-intercept and a y-intercept looks like. So remember, the x-intercept, you're solving for x. And for the y-intercept, you're solving for y. So you're plugging in a 0 for the opposite thing. So here, since I'm solving for the y-intercept, I'm solving for y. I would plug in a 0 for the x value, because I want to be solving for the y. So I have 8y equals negative 16. I would divide both sides by 8. And I have y equals negative 2, which means my y-intercept would be 0, negative 2. Okay? All right, so the last part of the notes is graphing standard form inequalities. Before we go into the inequalities, I do want to mention one oddball equation that you might run into. And let's say that you had to graph the equation 2x plus 3y equals 0. Let's say we had to solve this, right? And I was like, okay, since this is in standard form, I'm going to solve for my x and my y-intercept. So then you have your x-intercept on one side and your y-intercept on the other side. And again, this is just one of those like oddball equations where you have it equals 0. So for the x-intercept, I would plug in a 0 for the y. So I'd have 2x plus 3 times 0 equals 0. Well, 3 times 0 just goes away. 2x equals 0. Divide both sides by 2. 2 divided by 2 is just 1, so I just have 1x equals 0 divided by 2, which is 0, which means my x-intercept is 0, 0. Well, if I go over to the y-intercept and try to do the same thing, plug in a 0 for the x value because it's a y-intercept, 2 times 0 is 0, and then I have 3y equals 0. Divide both sides by 3. 3 divided by 3 is 1y, so just y. And then 0 divided by 3 is 0. So then I have the x-intercept of 0, 0, and the y-intercept of 0, 0. So then you're stuck with a dilemma because you're trying to graph it, and all you have is just one point. And you're like, I don't know where to put the rest of my line. I don't know where the other point would be. So the bad news is that if you do end up with a point that says 0, 0, or if you have a y-intercept and an x-intercept of 0, 0, that makes sense, right? Because 0, 0 goes through the x-axis and the y-axis, so it's both an x-intercept and a y-intercept. If you run into this situation, you're going to have to solve for y. So you're going to have to solve for y because even though you know that one of your points is 0, 0, you need at least another point so you know at least where to put your line. So you would have to solve this like an equation. So in order to get this into slope-intercept form, or y equals mx plus b form, I would need to subtract 2x on both sides. And then I would have 3y equals 0 minus 2x, which is just negative 2x. Divide both sides by 3, and and I have y equals negative 2 over 3x. So my slope would be negative 2, positive 3. So I would go down 2 and then to the right 3, and I would have a second point. So with this one, in order for you to actually be able to get more than one point, you will have to solve for y. And that only happens if you have a x-intercept and a y-intercept of 0, 0. Okay, so moving on to standard form inequalities. So just a reminder, remember inequalities are the less than signs, greater than or less than or equal to, and greater than or equal to. And if you forget which one less than is, remember the less than sign looks like an L so that we can write the word less than. So our less than signs are going to be this one and then this one. So those thicker ones, the less than or equal to and the less than over there. Okay, when you are graphing inequalities, you're always going to solve for y, regardless of the form. It does not matter if it is in standard form or in point slope form or in any other form. If you have an inequality and you are asked to graph, you need to get y by itself and use y mx plus b. So yes, these notes are over standard form, and these inequalities down here are in standard form. You need to solve for y. Do not try to find the x and y intercept because you will not know which way to shade, and even if you think you know, you might not know. Okay, so you always want to solve for y if it's an inequality. Now, if it's an equation, go right on ahead and do x and y intercept like we have been. But if it's an inequality, just solve for y. It is always the safe bet. Okay, so there are things to remember when you're graphing inequalities. There are two types of lines that we could have. So when we're graphing equations, our line is always a solid line. But when we're graphing inequalities, we could either have a solid line or a dashed line. When we have a solid line, that means that we either have a less than or equal to or a greater than or equal to. And the way that I have people remember this is that if you see a solid line under your inequality signs, then you have a solid line when you graph, okay? So only if you have less than or equal to and greater than or equal to. When you would have a dashed line is when it's just less than or greater than and no equal to line. So instead of having an open and a closed circle, we have dashed lines and solid lines. So if there's a solid line underneath your inequality, you have a solid line when you graph. Okay? Now, after you do that, you also have to question, do I shade above or below? So the times that you would shade above is when you have a greater than sign or a greater than or equal to sign. So if you have greater than, you would shade above. But if you needed to shade below, then you would have a less than sign or less than or equal to. So just think about something less, right? If something is less, it's below, okay? And greater than would be above. So if you have a greater than sign, you would shade above. If you have a less than sign, you would shade below. Okay, so we're going to go ahead and graph these inequalities in standard form. Now, both of these inequalities are in standard form, but because it's an inequality, I want to solve for y and get it into the y mx plus b form. Now, I just want to remind you that y equals mx plus b is the same thing as y equals b plus mx, right? They're still in both the y equals mx plus b form, they're just a little out of order. Just like how 5 plus 3 is the same thing as 3 plus 5. And negative 2 plus 5 is the same thing as 5 minus 2, right? Because you just have to make sure that your signs are the same. So if I have a positive 5 minus 2, I'm still going to get 3. And if I have a negative 2 plus 5, I'm still going to get 3. So as long as you take your signs with you, they are equivalent to each other. Okay, so we want to get y by itself. So the first thing I would do is I would subtract x on both sides. X minus x would be 0, and on the left side, I would remain a negative y. And then I would have a greater than sign still. Make sure you don't accidentally change it into an equal sign because you will forget about it. And then 5 and minus x are not like terms, so I would write them next to each other. Okay, now y is not by itself because there is a negative attached to it. And remember, the number that's really in front of it is a negative 1, right? So I would get rid of the negative 1 by dividing everything by negative 1. Every single term you see will be divided. Anything you do one side, you have to do to the other. Negative 1 divided by negative 1 would cancel and become 1, so I just have y on this left side. But since I divided by a negative, my sign, my inequality flips the other way. If I divide or multiply by a positive number, then my sign stays. But anytime I divide or multiply by a negative number, you have to flip the sign. 5 divided by negative 1 is going to be positive 5. And then negative x divided by negative 1, remember there is a negative 1 in front of this x. Negative 1 divided by negative 1 would be a positive x. Okay? So then now this is y mx plus b form, and I want to go ahead and identify my slope and my y-intercept. My slope here, remember slope is attached to your x, so mx plus b. So your m here is technically 1, and we want to be able to write that as a fraction, so it would be 1 over 1. The common mistake here is that people accidentally say that the slope is 5, but remember that 5 is not attached to the x, right? So that would be our y-intercept. So our y-intercept would be 0, positive 5. When I have slope-intercept form, the first thing I do is I graph my y-intercept. So I have a positive y-intercept at 5, and I would plot a point there. And remember, I have the slope 1 over 1, or I have the slope negative 1 over negative 1. Okay, so I'm going to go ahead and I'm going to use the first slope over here, 1 over 1, so that would be up 1 and then to the right 1. And I just want to make sure I did all of my math correctly. Yes, okay. That would be positive 1 over positive 1, or I could have negative 1 over negative 1. So you start back at your blue y-intercept and go down 1 to the left 1 because it's negative and negative. And then you draw a line through all of your points. Now you can do more, but you don't have to. This is a positive slope, right? And it makes sense because our line does graph a positive line. Always check to make sure your line direction and your slope are the same. They should both be positive if they are positive. All right, number 2, this is an inequality, so I need to solve for y in order to graph this. So I'm going to subtract 9x on both sides first. And I have negative 3y is less than or equal to 18 minus 9x. Ooh, I just forgot something, and I wonder if you caught it. So we just messed up here. And where did we mess up? Well, I messed up in a few places. Ooh, I got to go back. I wonder if you caught it. Maybe. Okay, here's where I messed up. I did 5 divided by negative 1, and I just wrote 5, but it's negative 5. I was wondering why this is looking different from yesterday. And guess what else? I forgot to ask if I had a dashed or a solid line, and I forgot to shade, so I would have gotten so many points off if this was a test. So I did not do that on purpose. I genuinely did forget. So let me go ahead and fix everything that I messed up on. So let me start back at the beginning here. The first mistake I made is when I did 5 divided by negative 1, I didn't put negative 5. So this would be a y-intercept of 0, negative 5. And then I would have a slope of positive 1 over 1 or negative 1 over negative 1. So my slope here was still correct, but my y-intercept was way off. So that would be negative 5. And then I think I can actually use the same slope over and over again, positive 1 over positive 1, because I have room. So again, I only need 3 points, but I'm going to go ahead just for this problem, do more than 3 points. Now before I draw a line through it like I just did earlier, sometimes you just do it by instinct, right? But you got to remember this was an inequality. So let me check back at the inequality that we have. Remember, we transformed this one into that one. So you don't want to look at the old inequality more. You want to look at the new inequality. So here I have a less than sign, not equal to. So there is no equal to line here, which means I'm going to have a dashed line. Okay, I'm going to have a dashed line here. And it's a less than symbol, right? It looks like an L. So I have a less than symbol here, which means I'm going to shade below. Below would be down here on this second region. So you want to shade below the line. And then let's talk about what solutions are. So solutions are located in the shaded region. Well, any point in the shaded region is considered a solution. So for example, I could pick the point 5, negative 2. 5, negative 2 lands in the shaded region. Okay, what about the point 0, 0? Well, the point 0, 0 lies right here, and it's not in the shaded region. So a non-solution would be considered the point 0, 0. But there's lots of points you could have for solutions and non-solutions, so you don't necessarily have to have these exact points that I have. Okay, moving on to this one. So sorry, I got sidetracked there. So let me just recap what we did on this problem. We just moved 9x to both sides, so we subtracted. And then now we're about to get the y by itself by dividing both sides by negative 3. And you divide everything by negative 3, every single term. Negative 3 divided by negative 3 is just positive 1, so I have a y here. My inequality sign is going to flip, and it's going to change the other way because it's going to be greater than or equal to now because I divided by a negative. Okay, I divided by negative, so my inequality sign is going to change. All right, the next step here is that I have 18 divided by negative 3, which is negative 6. And then I have negative 9 divided by negative 3, which is going to be a positive 3x. Negative 9 divided by negative 3 is positive 3. The most common mistake there is that we accidentally forget the negative sign when we leave it on. So you want to make sure that you're not doing that on accident. All right. The next thing that we are going to do, I'm so sorry, I'm doing something. Okay, I was doing something on my laptop and clicking. My bad. Okay, we are going to identify our slope. Our slope here would be positive 3 over 1 or negative 3 over negative 1. And then we have a y-intercept of 0, comma, negative 6. Did I divide 18 and negative 3 correctly this time? Okay, good. Just wanted to make sure. I messed up pretty badly on that last one, so I just wanted to make sure I was not messing up again. So our y-intercept is all the way down at the bottom, 0, negative 6. And then we have a slope of positive 3, so I'd start at my y-intercept, so go up 3. And it's positive 3 over positive 1, so I would go to the right one. Positive 3, positive 1. And before I draw my line like I did earlier without even thinking about it, here my inequality sign is a greater than or equal to. Greater than or equal to means I'm going to have a solid line because it's equal to, right? So I'm going to go ahead and draw a solid line through all of this. Okay? I have a solid line, and then I also have to shade. Well, this is a greater than or equal to. And greater than means I'm going to shade above my line. Above my line is going to be over here in this direction. It's going to be above. So for example, if we're talking about solutions and non-solutions, our solutions here would be 0, 0. Oh, I just threw my pen like across the table. 0, 0 is considered a solution because it lands in that shaded region. The point 1, comma 2. 1, 2 is also a solution. A point that would be a non-solution would be like 5, 0, right? Or 3, negative 3. 3, negative 3 is also a non-solution. So remember, solutions are in the shaded. Non-solutions are in the non-shaded. All right, so that is graphing standard form. With equations, you always want to just check for x and y intercepts first, and then you back up to that backup plan that we were talking about earlier. If you do get 0, 0 for both intercepts, you just solve for y. But you do want to solve for your x and y intercepts. With inequalities, always get the y by itself and solve it like slope-intercept form. Get the slope and then the y-intercept. And just make sure you shade, and don't forget, like I did earlier. If you have any questions, please feel free to come in for tutorials.